two types of transistor. This is an NPN. Let's denote this as IC, either IB pala. IC and IE. So, ang NPN, papasok si IB and IC, palabas kay IE. Therefore, we can denote at KVL IE is equals to IC plus IB. In an PNP naman, ay ang difference. Yung araw ko pasok. Ang difference dito, wala. Baliktad lang yung current mo. IE still IC plus IB, with the only difference sa NPN, papasok si IC, papasok si IB. Sa PNP, palabas si IB, palabas si IC. Yun lang yung difference niya. So let's derive some formula. Since ang tinakal natin is NPN rather, let's work our way around NPN. So from Bolyested's book, it states that IC is only approximately equal to IE. Ito pala, pag nakita mo to sa problem, like sinabi niya IC is squiggly line, squiggly over squiggly equivalent, approximate to IE. You can always denote that IC is equals to IC. IE pala. Unless hindi niya sinabi, huwag mo gawin to sa problem. So pag ginawa mo yun, mamali ka. And that doesn't happen kapag may given ka of two things, which is alpha and beta. Alpha, ito yung dahilan bakit approximate lang yung dalawang to. Kasi alpha is equals to IC over IE. Approximate. So, ang value niyan is ranging from 0.90 to 0.999999. Hindi yan magiging 1. Actually, 0.981 ata sa book ni Bolyested. Basta hindi siya aabot ng 1. Hindi yan mag-i-equal to. Always approximate to. So, kung IC, ito pala yung papansinin nyo is IC on beta and alpha are both numerators. Ang difference lang from the letter itself, B beta, IC over IB. Para natin, let's denote some alternative solutions para pag given sa problem beta, pero masasolve mo lang siya in terms of alpha. So let's work around this KCL. So, anong gawin natin from this formula? Let's multiply by 1 over IE. Plus IB. Mag-1 lang to, 1. And let's know IC over IE is equals to alpha plus IB over IE. So, ang gawin natin ngayon dito is lipat natin si alpha and mag-multiply tayo ng IE para ma-eliminate siya in the denominator. Therefore, we will have this IB. So, IE is equals to now, I multiplied to now 1 minus alpha. One of the many equations. IB is equals to IE times 1 minus alpha. So, let's do the same thing. Kaso iba naman. Let's say si C naman yun. IC of the function. IC plus IB. So, IE over IC. Ano ba yan? Hindi ba si alpha yan? Pero baliktad. Di 1 over alpha. So, let's say 1 over alpha is equals to 1 IB over IC. Hindi ka maka si beta over 1. Therefore 1 plus 1 over beta. Salpak natin to, beta. So we have 1 over alpha beta plus 1 over beta. Pero hindi ko ma-rater to. So gawin natin raise to negative 1. Or kung familiar kayo, parang ito yung ginagawa natin sa parallel in network theorems. So therefore we have alpha is equals to beta over beta plus 1. So habang andito na tayo, i-derive na natin yung alpha gamit to. So first thing gagawin mo, multiply mo si b plus 1, beta plus 1. So we have alpha, distribute natin, beta plus alpha. Ang ginawa ko lang dito is multiply ko yung equation by the numerator, kaya naging ganito siya, is equals to beta, beta, balibag natin si beta na alpha na may beta dito. Therefore we have alpha is equals to, factor natin beta, meron beta tayo 1. Pag dinipat mo ito, magiging minus alpha beta siya. So mag-factor si beta doon, alpha na lang. So therefore isolate natin si beta. Therefore beta is equals to alpha over 1 minus alpha. So ayun yung nangyari. So nag-IC na tayo, is na lang matitira si IB. So that's all. Same ginawa natin kanina. Let's multiply by IB naman of the equation IE is equals to AC plus IB. So immediately IE over IB is nothing, but IC over IB is beta plus 1. So multiply tayo ng IB, we'll have IE is equals to IB B plus 1 beta. Ayan na yung derivations ng many formulas. So kung titignan mo, parang pinaglaruan mo yung equation na to, and it is very similar to our Pythagorean theorem. Hanapin natin si IC, IB, and IE given our beta is equals to 50. This is a amplifier circuit. Ang gawin natin, since current yung mga hinanap natin from collector, base, and emitter, tanggalin natin mga capacitor. So mag-KVL tayo from source to emitter. So since from base to emitter tayo, pupunta tayo from base to emitter, we can denote that's BBE, pababa tayo. And since sabi niya is this function is an active component, is transistor, active siya, so 0.7, so equivalent siya. So silicon diode. With that in my KVL tayo, negative 20 plus IB RB plus BBE plus IE RE is equals to 0. So deriving that, negative 20, lilipat natin siya, IB RB plus IE RE is equals to 19.3 volts. Derive natin si IB from our earlier video. So IB now is equals to 1 minus alpha times IE yes, IE RB plus IE RE 90.3 volts. Kaso alpha gamit. So we know from earlier that beta is equals to alpha 1 minus alpha, and alpha now is equals to beta 1 plus beta. So kung ipa-plug in mo yung calculator, 50 over 1 plus 50, magkakaroon tayo ng alpha is equals to 0.90. So pasok natin mga values natin. IE from this equation, 1 minus 0.98, RB now is 3 kilo ohm. 3 3 kilo ohm plus IE din. RE is 1.5 kilo ohm is equals to 19.3. So let's factor IE. Actually, let's multiply this. 1 minus 0.980. So 0.02 times 3,000. You have 60 ohms. It's equals to 60 plus 1.5 or let's say 1,500. 1,500 is equal to 19.3. IE is equals to 61,560. 90.3 divided by 1,560. 0.0123 ampere. So with that in mind, may IE na tayo. And may alpha na rin tayo. So using our equation from earlier, 0.019, we can actually get already IC. Sa ginawa lang natin ito. So from one solving, we got it. IC is equals to alpha times IE and IB is equals to beta times IC and over IC. This is one of the many formulas earlier, pero let's stick with this. So 0.980 times 0.0123. Tama ba? Tama. IC will be given as 0.980 times 0.0123. 0.054. And using IB now, plug in natin si 50. 0.012054 over 50. IB is equals to 241.08 micro ampere. Nag-ineng ko lang siya. So let's have the second problem. We are finding VCE. We are finding VCE. So let's have, kunin muna natin si base. So given tayo ng VBE. And VBE is 0.7 as long as the transistor is an active component. So may 5 volts tayo. So ang loop, ang way ko pala is from whatever side you're entering. Itong 5V na to, positive 5V are the leading part. So kaya nakita mo kanina yung isa amplifier circuit ko, positive 20 lang lagi pero negative 20 ginap sa kanya. So negative 5 plus IB RB as RB is equals to 8.6 kilo ohm is equals to meron pa pala VBE is equals to 0. So bilipad natin, IB is equals to 5 minus 0.7, 4.3 divided by 8.6 divided by 8.6 will have 0.5 milliamperes, for the reason in that kilo itong si 0.826 rather. So with that in mind, kunin natin si IC muna. So naalala mo, IC over IB is equals to beta. So using that formula, IC is equals to IB, whereas our IB is 100 times 0.5 Therefore, we're left with 0.5, 50 milliamperes. So if may current ka dito na 50, let's use Ohm's law. So, or rather, there's Ohm's law, mag KBL tayo. So, negative IB, IC, RC plus VC is equals to 0. VC is equals to, lipad natin mga yan, plus, so we have 18 plus 50 times 100 ohm. Subtract lang. So we have 18 minus 50 times 100. We have negative. Nakakalit ito. Nakita natin sige. Times 10 raised to negative 3. Since milliampere. Times 100 ohm. 18 minus 50 times 10 raised to negative 13. Plus 100. Take off 13. 13 volts. So, nagsa-shortcut na ako. But let's not forget mga midi. Let's have this circuit. So, papasok natin from VCC. VCC kasi sa side na din siya, collector to collector. O VCC rather, collector, nagsusupply kay collector, pero connected siya dito. Excuse me. IC mo is equal to 5.2 milliamperes given sa problem, and IB mo is 10 microamperes. Our VCC is equal to 5.5. Find VBE. So from the earlier, VBE natin is always given since it's an active component. So in this problem, we don't know if it's an active or a passive. So actually, kung ganun mangyayari, we can solve this. Actually, paano ba natin solve si VBE? Alam natin pag dumaan tayo kay collector, tapos bumaba kay transistor, makuha natin sino? Si BCE. So let's instead go the other way. Konektado rin siya kay base. If you recall earlier, we can rewrite this equation as source, resistor, and our transistor. Resistor naman, ayan, ganyan lang siya from earlier, ground to. So let's say this resistor is equals to 100 kilo ohm. So if that's the case, may 5.5 tayo dito, positive. So let's enter the negative part. Negative 5.5 plus IB 100 kilo ohm plus VBE, lipat natin, VBE equals to 5.5 minus 10 micro. 10 times 10 raised to negative 6 of 100 times 10 raised to 3. So just like I said earlier, dito din may makasize niya. So 10 times 10 raised to negative 6 plus 100 times 10 raised to 3. Therefore our VBE is 4.5. An NPN transistor circuit has an alpha of 0.985. If IC is equal to 2 milliamperes, then IB is equal to what? So IC and IB. Yung hinahanap natin IB in terms of IC. So tanggalin natin si IE. Pero alam natin si alpha is work alongside IC and IE, hindi IB. So ano bang gagawin natin? Well, we know that beta is equals to IC over IB. So, i-convert natin si alpha into beta. And beta is equals to alpha over 1 minus alpha, giving us 65.8 0.67, 0.985 over 1 minus 0.985. And let's work around this. So IB now is equals to IC over beta 2 milliamperes all over 65.67, giving us IB is equals to 0.030 milliamperes. Given this equation, find IB. And VBE is negligible. So, huwag natin siyang pakilaman. But we have a given of VCE, collector to emitter voltage, is equal to 7 volts. And V, ang beta natin is equal to 100. Find IB. So, first of all, let's solve for IC muna. So, KBL tayo. We have a voltage source of 15. So, negative 15 plus IC. Bakit ba IC? Bakit ba tayo mag-diretso? Excuse me. So, if you can recall from a real problem nga, beta is in terms of IC and IB. So, IC times 2 kilo ohm plus VCE is equals to ground. Therefore, silan siya. So, balabag natin mga kailangan balabag. IC is equals to 15 minus 17. So, we have 8 ba? 15 minus 17, yes, 8 over 2 kilo ohm, giving us 4. Diba? Nag-calculate pa ako. 4 milliamperes. So, pansin mo sa problem, wala kang giving voltage dito. That's because di ba naman siyang gagamitin? We have beta. Beta is equals to IC over IB. Ang kanina IB IC over beta. So paulit-ulit lang. 4 over 100 giving us 4 over 100 0.04 milliamperes.